So this video is on geometric sequences and then geometric series. So for a geometric sequence, this is something we saw in integrated 1. And a geometric sequence is generated by multiplying by the same number. So geometric sequence is generated by multiplying by the same number. I'm going to go over two examples. So one example would be 3, 6, 12, 24, ... So in this example, we are multiplying by 2. And that multiplying by 2, that is our common ratio. Which is R, and our R is 2. Let's say we have an example like 100, 50, 25, 12.5, ... Now you might think of this one as dividing by 2, but you want to think of it in terms of multiplying. So if I'm dividing by a number, I'm really multiplying by the reciprocal. So I'm multiplying by 1/2. So my R in this case is going to be 1/2. Now, in order to write an equation for a geometric sequence, the general equation is going to be the following. So general equation for geometric sequence. Now, in integrated 1, we usually started with our 0, okay? So if I'm starting with my 0, so if I have a sub 0, okay, then I'm going to have a sub n is equal to a sub 0 times r to the power n. That's for a sub 0. Now let's say I start with a sub 1, which is my first term. That's usually how we're going to start. So if you're starting with your first term, you're going to have a sub n is equal to a sub 1 times r to the power n minus 1. And for example, let's say I had my 5th term, just to show us. So if I knew my 5th term, fine, start with your 5th term. That's going to be a sub n is equal to my 5th term, a sub 5, times r to the n minus 5. So what you want to notice is if I have a sub 1, then this is an n minus 1. If I have a sub 5, then this is an n minus 5. But again, usually what we're going to have is this one right here, because usually we will be starting with our first term in our sequence. So let's say I wanted to write an equation for the 3, 6, 12, 24, ... So for this one, I would start with my first term, and my first term is 3. Okay, again, this is my a sub 1, and I am timesing by 2. This is my r. And since it was my first term, I'm going to do n minus 1. And that would be the equation. Now, let's say I was dealing with the second example where I had 100, 50, 25, 12.5, ... So in this case, again, I'm going to start with my first term, which is 100. I'm going to multiply by my multiplier. Whenever it's a fraction, I put it in parentheses, so times it by 1/2, and then to the n minus 1. And that would be the equation for that one. Now, sometimes they're going to ask us to find a particular term in a sequence. So let's say, for example, they want us to find a term. So let's say in this example, I want to find the 20th term of the following: 0.5, 1, 2, 4, ... So in this situation, I am going to write a general equation. A sub n is equal to, start with my 1, which is 0.5. That's my first term, I should say. Multiply it by my multiplier, my common ratio, which is 2, raise to the n minus 1. That would be the equation. So if I want the 20th term, and that's what I want to find, a sub 20, then I'm going to go 0.5 times 2 to the 20 minus 1, or 19. And so when I put this into my calculator, and here I'm just going to get Desmos here. Okay, so if I'm putting that in, I'm going to get 0.5 times 2 raised to the power. And if I want to do this on Desmos, I have to be careful, because if I go 20 and then minus 1, see how it drops. So if I want to raise it to the quantity 20 minus 1, I need to put it in parentheses. Okay, so this is going to be, whoops, let me grab that one more time. So it is going to be 262,144. So 262,144. That is our a sub 20. Okay, so next idea, we're going to move into series. So this next set of notes is going to be dealing with geometric series. So geometric series. And so this is when we're taking a geometric sequence, which is generated by multiplying, but I'm going to add the pieces together. So for example, the 3, 6, 12, if I was to take 3 plus 6 plus 12 plus 24 plus ... that is a series. Let's say that we are adding this up to 384 plus 768. So let's say this is what we were doing. I'm going to show us 2 ways to do this. So one way to do this is to do the following. I am going to take S sub n, which is going to be 3 plus 6 plus 12 plus 24 plus ... plus 384 plus 768. Okay. Now, this is one way to do it. I'm going to give us an equation here in a sec, but this is one way to do it. So in this situation, I was multiplying by 2 to generate the numbers 3, 6, 12, 24. So what I'm going to do is I'm going to take 2 times my S sub n and see what I get. So I'm timesing everything in this equation by 2. Okay. So when I do that, I get 2 times S sub n. Now 3 times 2 is 6. I'm going to line it up underneath this 6. Now I'm going to take 6 times 2, which is 12. I'm going to line it up under here. And 12 times 2, which is 24, I'm going to line it up under here. 24 times 2 is 48. And I would have had a 48 here. I just didn't list every single term. Plus ... When I take my 384 and times it by 2, I get 768. So let me line that up under 768. Then I'm going to take 768 times 2, and that's going to be 1,536. So what I'm going to be doing now is I'm going to be multiplying this whole entire equation by a -1 so that I can minus it from the first equation. So if I was to take that equation and multiply it by a -1, so this whole equation is multiplied by a -1, and so I would get -2 S sub n is equal to -6, -12, -24, -48, -768, and -1536. And then what I'm going to do is I'm going to take this equation, and I really was minusing with this, but now that I made everything opposite, I can just kind of combine them. So when I do that, I am going to end up getting my S sub n minus 2S sub n is a -S sub n. 3 has nothing to cancel with. Now what's going to happen here is the 6 and the -6, this 6 and this -6 are going to cancel out. This +12 and this -12 are going to cancel out. This +24 and this -24 are going to cancel out. Now, really, there would have been a 48 here. I just didn't list it, and that's going to cancel with this -48. And that's going to keep on going. Here, this +38 would have canceled out with a -384 that would have been down here. And this +768 cancels with this -768. So basically everything canceled out except for the 3 in front and that -1536. Now that's going to be -S sub n is equal to a -1533. I divide both sides by a -1 and I get S sub n is equal to 1533. And that would be my sum. That's one way of thinking about it. I'm going to do this one more time with numbers, and then we're going to try it with a general equation. So let's say that in this example, I have 5 plus 15 plus 45 plus ... plus, and they go all the way up to 10,935. Now, what's happening in this situation is I am timesing everything in this by 3. So my R is a 3. This is a 5. Sorry, it looks like kind of like an S. So I'm going to do what I did above. And I am going to write this as S sub n is equal to 5 plus 15 plus 45 plus ... all the way up to, again, 10,935. Now I'm going to take this equation. I am going to multiply this equation by 3, because that's what I multiplied everything by to get the sequence. So when I do that, I'm going to have 3 S sub n is equal to, and when I multiply 5 by 3, I get 15. So I'm going to put it underneath the 15. 15 times 3 is going to give me 45. So I'm going to put it underneath this. Plus ... And I'm going to keep going. I'm going to multiply this by 3. When I multiply that by 3, well, let me say this. When I multiply the term before this by 3, I'm going to get the 10,935, okay? And then I'm going to multiply this by 3, and I get 32,805. So again, what I'm going to do is I'm going to basically subtract these two equations, but let me just show that I would be multiplying this by a -1. I'll just put by a negative. So I am going to get a -3 S sub n is equal to a -15, a -45, a negative ... negative 10,935 minus 32,805. So I'm taking my S sub n equation and I'm going to minus it, or now combine it with this one here. So I'm going to combine the two green ones I have. So when I do that, and I take S sub n minus 3 S sub n, I get a -2 S sub n. And here the 5 has nothing here to cancel with, so I'm going to be having the 5. My 15 and -15 cancel, my 45 and -45 cancel. Every one of these terms continues to cancel. This one cancels with this. And then I'm going to be left with what my last term multiplied by the R was, which is minus 32,805. So I'm going to get -2 S sub n is equal to -32,800. I'm going to divide by -2, divide by -2, and I get S sub n is equal to 16,400, and that's my answer. Okay, so now what if I was doing this in general? So if I'm doing this in general, what I'm going to do is I am going to have as my example, I'm going to be adding my first term, let's say that's a sub 1, with my second term, let's say that's a sub 2. My third term is a sub 3 plus ... and my nth term is a sub n. And in this situation, let's say that my common ratio is equal to r. Okay, so what that means is I can rewrite this as S sub n is equal to a sub 1. Now, instead of writing a sub 2, it's really going to be a sub 1 times whatever my r is. So I'm going to write this as a sub 1 times r. And then to get my next term, I'm going to take this term, a sub 1 times r, and times it by another r. So my third term is really a sub 1 times r to the second plus dot, dot, dot. Now, my nth term here would be a sub 1 times r to the n minus 1. That's what this one is going to be. And then I am going to times it, everything in this equation, by my common ratio, which is r. So when I do that, I am going to get a negative, sorry, not negative yet, r times s sub n is equal to r times a sub 1. This one's going to be, here, I'm going to write it like this. A sub 1 times r. A sub 1 times r to the, and let me line them up. Sorry. So I am multiplying everything in this green equation by r. So this times r is this. This times r is a1 times r. This one here times r is going to be a1 r squared. So I'm going to write it here. Plus dot, dot, dot. Okay, and I'm going to keep doing that, keep doing that, keep doing that. All of these are going to be lined up. Now this one here, what's going to happen is the term before that would have given me an a sub 1 times r to the n minus 1. That would have been from the term right before this. And now if I'm taking this last one and I'm timesing it by an r, I'm going to have a sub 1 times r to the n, not the n minus 1. Okay, so now I'm going to multiply this whole thing by a negative. And I'm going to get negative r times s sub n. I get an a1 r, a minus, because I'm multiplying by a negative. A minus a1 r squared, a minus dot, 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 a1 r to the n minus 1, minus a1 r to the n. And now remember, when I'm doing that, let me write that better. So now when I'm doing this, and I'm taking this top green one and this bottom green one, and I'm combining them, what is going to happen is the following. When I take s sub n minus r s sub n, I'm going to get an s sub n minus r s sub n, and I'm going to clean that up in a second. Now here, my a1 is going to remain. My a sub 1 r is going to minus with my a sub 1 r. My a sub 1 r squared is going to minus with my a sub 1 r squared. Everything's going to cancel out until I get to this very last one, which is going to be minus a sub 1 sub n r to the n. And I put, that should be an a sub 1. I apologize. It was this same one, just negative. So let me change this. Sorry, this is an a sub 1 r to the n. Now, what I can do here is that I notice I have an s sub n here and an s sub n here. So I can factor out S sub n, and I'd be left with a 1 minus r. Over here on this side, I can factor out an a sub 1, so I have an a sub 1 in both of those. And when I do, I'm going to have an a sub 1 times 1 minus r to the n. Now, the last thing I'm going to do is I am going to divide both sides by 1 over r. So I'm going to get S sub n. And again, when I divide this by 1 minus r, it's gone. I'm going to also divide this side by 1 minus r, which gives me a sub 1 times the quantity 1 minus r to the n, all over 1 minus r. This equation that I just got here is the equation to find the sum of a finite geometric series. So let me just put up here. I don't think I wrote it up here. I am, did I write the word sequence again? That's a mistake. I apologize about that. It's not going to be sequence. This was a series. Okay. So this right here, let me erase that. This right here should have been geometric series. Okay. That's when I'm summing them. And this one is called a finite one. Yeah, I'll write the word finite. Finite just means it ends. I'm ending somewhere. I'm not adding up forever and ever. So I am going to add in on the next page this formula. Okay. So the formula for the finite a finite geometric series is the following. S sub n, which is the sum of the first n terms, is equal to a1, which is the first term, times 1 minus r, which is my common ratio raised to the power n. That's how many terms we're adding. Close the parenthesis. Notice the n is not outside of the parenthesis. It's just the r that's being raised to the power n, all over 1 minus r. So this is the equation. So if I go back to the two problems I had tried earlier, one of them being 3 plus 6 plus 9 plus 12 plus 24 plus ... all the way up to 768. Okay, I can use this formula. The only issue is that in this particular situation, I don't know what term that is. So I need to find the term. I know what my R is. My R is going to be 2. I know that my A sub 1 is going to be that 3 in the front. So what I need to find is what term that is, because that's going to determine my n. So to find that term, I need to write a geometric sequence equation. So a sub n is equal to 3, which is my first term, times my multiplier, my common ratio 2, raised to the power n minus 1. So if I want to figure out what term 768 is, that's going to go in for my a sub n is equal to 3 times 2 to the n minus 1. I need to solve this. I'm going to divide both sides by 3. And when I do, I get 256 is equal to 2 raised to the n minus 1. Now, what I would do in this situation, once you get your 2 to the power by itself, use logarithms. So I'm going to rewrite this in log form. So this is going to be log base 2 of 256 is equal to the exponent n minus 1. So I am going to put this into my calculator. So if I'm trying to do this in Desmos, what I can do, a couple things, you can come over here to functions. And let me just make this a little bigger. Come here to functions. Try it again. Come here to functions. And you can scroll through here and see that you do have logarithms right here. You can come here and get this log. Okay. Now you can also do this and just type in log, and to get the base, do shift and the dash or the underscore, 2, arrow out, 256, and I end up getting an 8. So log base 2 of 256 is 8. So when I come back here, this whole thing is just an 8 is equal to n minus 1. So when I add 1, I get 9. So I know that 9 is my term that gave me the 768. That's my 9th term. So if I want to find S sub 9, I'm going to start with my first term, which is 3. I'm going to multiply it by 1 minus my r, which is 2, to the power 9, all over 1 minus 2. And I can put that into my calculator. So I'm going to get my fraction bar. I'm going to go 3 times the quantity, 1 minus 2 raised to the power 9. And I'm doing shift and 6 to get that. Divided by the quantity 1 minus 2. And you see I got the same answer that I got on the other page, 1533. So this is equal to 1533, 1533. Again, that's the same thing I got right here. Different ways of thinking about it. Okay, now I'll try this one here, which gave me 16,400. That's what I should be getting. So if I'm doing this one, and let's say in this example, we had 5 plus let me just double check it. 5 plus 15 plus 45. Plus ... And we went all the way up to 10,935. Now, again, we know our A1, because remember for this, we need this formula. S sub n is equal to A1 times 1 minus r to the power n, close your parenthesis, all over 1 minus r. And I'm going to put that in parentheses. That's what we need. So I know my A1 is 5. I know my r is 3 because that's what I'm multiplying by. I need to find my n. That's what I need to find. And to find my n, I am going to take this term right here and figure out what it is. So I know that a sub n is going to be 5 times 3 to the n minus 1. So I know that 10,935 is equal to 5 times 3 to the n minus 1. I'm going to divide both sides by 5. And when I take 10,935 divided by 5, I get 2,187 is equal to 3 to the n minus 1. I'm going to go log base 3 of 2,187 equals n minus 1. And again, when I put that into Desmos, I'm going to type in log, shift in the underscore, and this is log base 3 of 2187, close my parenthesis. That is a 7. Okay, so this whole thing here is 7 is equal to n minus 1. So 8 is equal to n. So I know my n now. My n is 8. So when I work this out, I am going to be trying to find s sub 8 is equal to my first term, which is 5, times 1 minus what I'm timesing by, which is 3, to the power 8, all over 1 minus 3. And I'm going to put that into my calculator. And when I do that, I'm going to put my fraction bar in first. And I'm going to have 5 times 1 minus 3 raised to the power 8 over. And if I have the fraction bar, I don't really need the parenthesis, but if you don't do it as a fraction bar, you want to make sure you put parentheses. And I get 16,400. So this is going to be equal to S sub 8 is going to be equal to 16,400, which was the same answer that we got here. Okay. Now, next time we're in class, we're going to be practicing doing these, and we're going to learn about infinite sequences, or sorry, series.